Today, we're diving into a story that honestly feels like it's been ripped straight out of a sci-fi novel. We're talking about a completely new quantum framework, a set of absolutely astonishing claims, and a single lone researcher who's decided to take on the entire scientific establishment. You're gonna want to hear this. Okay, so let's just start with the results because they are staggering. In live tests on actual quantum cloud computers, this framework supposedly hit 99.22% overall accuracy. Now, for anyone who knows quantum computing, that number is, well, it's almost unbelievable.
And then you see the error rate. It came in at less than 10 to the negative seventh. To give you some perspective, that is more than 100 times better than the typical quantum systems we're using today. It's a huge leap forward. And if that wasn't enough, there's the efficiency. When they ran it on live cloud hardware, it used almost 30% less energy. So it's incredibly accurate, has a vanishingly small error rate, and it saves a ton of power. This seems like a slam dunk, a breakthrough on every single level. But this is where the story gets really interesting.
Despite these incredible, seemingly validated results, the work was rejected. Everywhere. Not just once or twice, 22 different submissions to 22 different venues, and every single one came back a no. And the reason they gave? It wasn't that the math was flawed. It was that the whole idea was just too different.
So who's the person behind all this? It's the work of Jeremy Baker, an independent researcher, who, after hitting that massive brick wall with academic publishing, decided, you know what, forget this. I'm taking a different path. So what is this revolutionary idea that was just too strange for the establishment? Well, it's a concept he calls inversion duality, and it basically flips our entire understanding of what an error is completely on its head. This right here is the fundamental shift in thinking. For decades, our approach to computing has been to treat errors as random noise, something messy that we have to fight and suppress. This new framework says, wait a minute, what if that opposition isn't noise? What if it's actually part of the structure, something we can use? And this is the core concept, inversion duality. The idea is that instead of having one system trying to fight off errors, you create two systems that are perfect opposites, perfect complements. They exist in a state of balance. So any information that seems like it's lost or corrupted in one state isn't gone at all. It's perfectly preserved as predictable information in its mirror image state. And the mechanism to achieve this is actually super elegant. It all boils down to a pi phase shift, or put more simply, a 180-degree flip. If you remember anything from high school physics about waves, this is going to click right into place. Just picture two identical sine waves. Now imagine you take the second wave and you flip it perfectly upside down, a 180-degree shift. So now when the first wave is at its highest point, its peak, the other wave is at its lowest point, its trough. They are perfect mirror opposites. And this is the magic right here. Separately, they're just waves, but together they create a single, complete, and incredibly stable system. And this is the formula that captures that beautiful idea of balance. You really don't have to be a mathematician to get the gist. You've got your main state, C of x, and its perfect opposite, the inverted state. The totally stable system, which is that psi symbol, is just the combination of the two. Stability isn't something you have to force onto it. It just emerges naturally from this perfect opposition. Okay, so that explains how it works. But why is this system so fundamentally stable? Well, the secret to that lies in the geometry of the universe it's built in. So why is this an 8D framework specifically? Why 8 dimensions? According to Baker, it's because 8 is the absolute minimum number of dimensions you need to create a geometry that can support these special kinds of symmetries. They're called octonionic symmetries. Basically, it's the simplest possible universe that's just complex enough for this kind of perfect, balanced opposition to even exist. And here's the other critical piece. The system is topologically locked. Think of its 8D universe as being a closed loop, like a donut shape. There's no way for information or errors to just fly off into infinity. Everything is contained. This structure makes the system fundamentally immune to decay and randomness, to entropy. And that's why it can achieve perfect 100% reproducibility, time after time. Right, so now we get to the part where the implications just get, well, they get wild. Because this core idea of inversion duality, it isn't just a neat trick for quantum computers. Baker is proposing it as a foundational framework for pretty much everything.
I mean, just look at this proposed roadmap. Step 1 is what we've been talking about, building these incredibly stable, fault-tolerant quantum computers. Okay, cool. But from there, you can create unbreakable cryptography that even quantum computers can't crack. And then, it gets even crazier. You move on to designing AI, where fairness isn't just a rule you code in, but an actual property of its mathematical structure. And from there, you can engineer things like decentralized organizations that are structurally, mathematically fair. This, right here, is easily the most mind-bending claim of them all. The idea that in this framework, you don't teach an AI to be ethical. You don't program a list of do's and don'ts. Ethics becomes a mathematically unavoidable outcome of the system's geometry. For the system to even be stable, it has to be fair. So how on earth does that work? It's through something called Type 3 inversion symmetric solutions. In this kind of system, any solution that represents pure self-interest at the expense of the whole group is mathematically unstable. It literally collapses. But the same thing happens for pure self-sacrifice. The only stable, sustainable state, the only one the math allows, is one that finds the perfect balance point between the good of the individual and the good of the collective. And that brings us right back to today. Faced with 22 rejections for a framework that he believes could literally change the world, Baker made a radical decision. He decided to just walk away from the traditional system of science. He was clearly frustrated with a system that he felt valued fitting in more than it valued actual innovation. So he bypassed the gatekeepers completely. He released everything online, every research paper, all the source code, all the validation data from the quantum computer tests. It's all out there for anyone in the world to see and to verify for themselves. This quote says it all, doesn't it? It's not just about one person's frustration. It's a statement. It's a declaration of independence from the established closed-door process of peer review and a bold move towards a more open, decentralized vision for science. And this is his message to all of us. By putting everything out there in the open, he's effectively saying you don't need to wait for a journal to tell you if this is real. If you have the skills and the curiosity, you can check the work yourself. The gatekeepers are gone. The entire world is now the peer review committee. So at the end of the day, we're left with this huge, fascinating question. Is this 8D quantum framework a genuine, game-changing paradigm shift that was just unfairly shut down by a system that's afraid of new ideas? Or is it a beautiful, incredibly complex, but ultimately flawed delusion? The data is public, the code is out there, and now the world gets to decide.